Afternoon all and welcome to Python coding lesson 4. Today's lesson will be continuing with the if statement that we started yesterday. So to quickly have a recap of that if statement I just showed you briefly yesterday, it was in order to use conditions in programming. That means if you want to test if something is equal, something's greater than, if something's less than, we normally use what we call an if statement. And the syntax for an if statement, well, the first syntax we're going to learn for the if statement is if followed by a condition. Now that condition can be any type of condition that is checking that can give us an answer of true or false. For example, is your age equal to 16, or is your age equal to 14 or 13? With one of those conditions, you would either tell me yes or no. So any question that you can answer yes or no, we refer to them as true and false. Yes being true and no being false. So when we use the syntax, we go with the if condition. Let me just get my pen. All right, so we go with the if condition. So remember, this has to give us an outcome of true or false. If it's true, the work that we put into the second block here will be run. That means now you'll notice that this is also pushed in compared to where the if is. And this is called indentation. Indentation is when we push our work in, and this symbolizes the begin and end of our condition. So if this condition is true, what must we do if the condition is true? So what program must run if this condition that we give it is true? Then we have our first we need to know that the if statement will only run if the condition is given is true. So is 5 less than 7? You'll tell me if it's true or not. And in this case, is 5 less than 7? Yes. So in this case, it'll give me an answer of true. So this part here will run. So what must we do if it's true? Say 5 is less than 7 or 7 is greater than 5. Some sort of answer or processing or display that we can use when the condition is true. The line after the if condition is indented. This means that this line of code will only be read if Python reads the condition as true. So that means because it's indented here, this line of code that we have in this line here will only run if this condition is true. Now, before I go into too much detail of the conditions, let's look at some of the operators that we can use in the conditions. I showed you all yesterday one of the operators was the equal operator. Now, because a single equal to sign in Python means take whatever's on the right and save it on the left. So whatever's on the right hand side will be saved on the left hand side. That's what a single equal to does. So in order to check if something is the same, we use two equal to signs. So this is our comparison equal to. Then we have the exclamation mark equal to sign. The exclamation mark equal to sign means not equal. See, it means not equal. So I can go, is A equal to B? So if I go with A is 3 and B is 4. In this case, the answer here would be false. A is not equal to 3. Then I can go look at the next one. Is A not equal to 4? So is A not the same as 4? This answer will be true. So the program will run then. Again, go and look at the next one, which is greater than. Greater than sign is just like in our maths, greater than. I look at, is A greater than B? Is 3 greater than 4? In this case, our answer will be false. Then, looking at the next comparison sign, we've got is the greater than equal to sign. Now, when you use greater than equal to, you put both the signs greater than and equal to followed by each other. Please do not put it the other way around. It's always greater than equal to, therefore you'll put down the greater than sign first, then the equal to sign. Right, so if I go look, is A greater than equal to B? Is A greater than 4? No. Is it equal to 4? No. So in this case, our answer will be false. I know I left out one of the signs in between both, which is the less than sign. So if I look, the less than sign is our normal maths less than sign. I can go. Is 3 less than 4? Remember, it'll always read from left to right. So is A less than 4 or A less than B? A is holding 3. So I'm going to also put down the capital A here and the capital B. Because remember, Python is case sensitive, so small a and capital A is different. So is A less than B? The answer will be true. Is A less than equal to sign? Again, just like the greater than equal to sign, it's always for the sign is always followed by the equal to, not equal to greater than, right? So less than equal to is A less than equal to B. Answer here is also true. So these are the operators that we can use in comparison. If you remember from yesterday's work, we did we did one program with comparison in it. I'm just gonna pull it up now. Oh, seem to have lost it. Okay, right. It was this one here. Create a maths program for the user. So we said, okay, we're going to generate two numbers for the person to do addition with. So we create a little addition game. We said, okay, we're going to ask the user what's the numbers, and we're going to store the answer for those two numbers. At this point, we don't know what the numbers are because it's randomly being generated. It'll always change. Sometimes you may get the same number, but that's random. So we look at the answer, we said, okay, and we worked out the answer since we're only doing the addition. I said the first number plus the second number must be stored in answer. So remember, right-hand side is saved in the left-hand side whenever you see an equal to sign. So taking and adding the numbers is stored in answer, and I said, if the user's answer is equal to is so in other words, is the user's answer the same as the computer's answer, my answer that we worked out? If it is the same, it means they got it right, so we message them congrats. Then if the user's answer is not equal to, it's not the same as my answer, because remember, my answer is going to be the correct answer. Well, the user's answer, that's what we are going to check, whether it's equal to mine. So I said if it's not equal to my answer, then I'll message sorry. And that's how we got the program for the maths one. 7 plus 4, and if we go 12, sorry, the wrong answer. But if we put in the right one, module again, 2 plus 9, this time we put in the right answer, it'll give us 11. And so it says congrats. So we can see we create a little game that every time we run it will give us different numbers to add and display. So we can test our maths in this kind of way. And you can not only do it for addition, but you can change the program around and do it for multiplication, division, subtraction. It doesn't only have to work for addition. And to do that, all we really need to do is change the addition into subtraction. And that's all we have to do. And of course, we'll message the user. It won't be addition anymore, it'll be subtraction. So we can change around the program. We can create different programs to do different things. I can create this one program to do addition. I'm going to put that back as addition. And since we have code and we can copy and paste code, we can just highlight the entire thing. I'm going to go copy. I'm going to go at the bottom and paste. But this time, I'm going to put subtraction. So if I'm subtracting there, we put subtraction there. And now if I run it, we'd have two bits of games. The first one being what is 6 plus 6? So you've done 12. They say that's congrats. 5 minus 3. I can put down 2. And again, I got it right. You see, because this is being done under a if condition, I can add on to my program to work out a score if I wanted to. For example, using the same bit of code, I can go, okay, let's start off with our user score at 0. So I go score is equal to 0. So now I can keep track of every time the person has it right. And if I look at the if statements, let me put in lines so you can see which line I'm talking about. So if we look at line number 15 and line number 18, that's this line here and this line here. If we look at those two lines, which line means that the person has the correct answer? Yes, line 15. So if the person comes into line 15 and gets it right, I can increase the score in line 15. So because I want to increase the score, I'm going to say, okay, let's take what the score is, so whatever the score is, and I'm going to add 1 to it. So what this simply does, it looks at what is currently saved in score? 0. 0 plus 1, 1. So whatever score has, I'm going to add 1 to it. I can do the same thing with the second part. I can say, okay, this is also when the person's got it right. So I can go score is equal to score plus 1. So this way, I'm calculating a little game to calculate how many answers the person has right. So at the end of it, I can go, okay, print, you have a score of score. Because score is string, oh sorry, because score is integer, I need to change it to a string. I can say score. I can put down another plus sign. Say put in the division sign to look like it's out of, and I can say 2. So now if I run this program, I'm just going to say, oh, literal. You have the score out of, oh, forgot to end the quote sign. So the computer didn't know when the quote was stopped. There we go. A plus 6, I'm going to go 4. B minus 6, I'm going to go minus 3. And, oh, made a mistake. Print, you have a score of int out of that. You can only concatenate string, not int. Oh, I said one thing and I did another. So I can only concatenate string, not int. I did the wrong conversion inside the block. So go back to the block. I said I'm going to convert it to string, but I converted it to int. Right. When I quickly run this again, right, 5 plus 8. Go there. Now, damn, don't know what happened there. Let's try it one more time. 8 plus 2. Let's type in. So the 2, and I go 2 again. You notice I have a score of 1 out of 2. So I can change my program. If I add on more questions, it can ask more questions to the user. And I can determine whether it's addition, multiplication, division, and all that's going to be done is I'm going to be checking against the if statement. So that's how we change this to be a little type of game for a person or a little testing program. You can test your little siblings to see if they know how to add, subtract, and multiply integers. All right, so Now, of course, the little division of integers, unless it's equal, will be a little bit tougher for them, but of course, you can always try. Right, so that's the program that we did yesterday, which I just added on to. So we look at the next part. Let's try some questions. Write a program that will allow a person to enter in the age and display if the person can vote or not. So we're going to quickly open up a program. I'm going to say file save. Save this as vote. Right, so if we look at the question again, let's pull it up. Write a program that will allow a person to enter in their age. So we're going to get the person's age. So that's going to be our input. The input is the age. Now we're going to display if the person can vote. So we are displaying person can vote or not. So this is our output. So now we need to figure out what our processing is going to be. And if we look at this, our processing can only be determined if we know what the age for voting is. And if we look at the voting age now in South Africa, we can say that the voting age in South Africa is 18. So if we look at it, a person that is equal to 18, ooh, yeah, right, a person that is equal to 18 or greater than 18 can vote. And if we look at our operators, we're looking at something that is greater than equal to. So it has to be this operator we're going to be using. So let's try a program out. So we're going to have our inputs. In this case, we are not importing anything. So the import will be blank. We can have our input. We can have our process. And I'm going to leave out the output part because when it comes to if statements, we can either have the outputs in the process itself or outside. So sometimes you'll process and output at the same time, sometimes you won't. So I'm going to just leave out the process output for the time being. So let's start with our input. Our input is age. So we're going to say age is equal to the input of the person. So if I look at, this would be what is your age? Give me a second. All right, so what is your age? And the next part is I can convert the age because when our comparison is, we're comparing it to other numbers. So I'm going to say, okay, age is equal to int age because we're going to compare it with a number. So my next step, my processing, is how do I determine if a person can vote? If a person can only vote if the age is greater than equal to 18. So I go, okay, if the age that I have is greater than equal to 18, then I can vote. And you notice I put a colon at the end. Don't forget that part, otherwise the computer won't indent for you. So I can go, okay, the age is greater than 18. I can print. You can vote. Else now, I can say, okay, if the age is less than 18, because I can't put not greater than equal to, right? I can only use the operators that I just showed you all there. So I say the age is not greater than equal to 18. That means they obviously must be less than 18. So if the age is less than 18, I say, all right, print sorry, still cannot vote. And now we can quickly run this. Yes, I can save it. I enter in the age, enter in the age 17. It says, sorry, still cannot vote. But now if I go and put in the age, 22, I can vote. What happens if you put in an age that's equal to 18? You go 18, and it says I can vote. Because remember, when we programmed it, we said if I can be greater than 18 or equal to 18. That's what greater than equal to means. All right. So that's the little first program that we do. Next, let's try the next one. Write a guessing game program, or sorry, write a guessing game program that will generate a number from 1 to 10. So we're going to write a program that's going to generate a number from 1 to 10. So if we look at this program, we are going to be using the random module. So I'll need to pull in random. So under our import in this program, I'll need to make sure that I use random. And allow the user to guess the number. So if we allowing the user to guess the number, that means that this part here is going to be my input. I'm going to have an input from the person to guess the number. And finally, I'm going to display a message to indicate if the user has guessed it correct or not. So this is going to be my output, my display part of my work. So right, let's open up a program and try this. Now, whenever you're working with programs, make sure that you save your work, as well as when you start off, you know what your input, processing, and output is, so that you know what you are doing in the program. Right, so we start off our program. We're going to have our import. And in this case, we are importing something. And what we importing is the random module. The reason we need to import the random module is because if we look at the question, it told us we need to generate a random number from 1 to 10. So it needs a random number. So the first part is to get our person's input. So we're going to have input. You can say, okay, user guess is equal to input, and I get the person's number. So I'm saying them enter in a number from 1 to 10. Or I can put a message like, guess what number I'm thinking of. Right, so I'm giving them the number range 1 to 10 to guess a number. Right, next step, I need to convert this guess into an integer because currently it is a string. So I go user guessed. Oh, user guess is equal to int, pressing all the wrong buttons, user guess. So now this converts it into a number, so I can check it against. So in order to check this number against a random number, I need to generate the random number. So the next line is to do the processing. So my process will be to generate a random number. So I go, okay, my number, or the guess number, is going to be equal to random
dot rand range, because that was how we generate random numbers. For some reason, I can't type. Okay, random range. And I'm going to say, okay, go from 1, and I'm going to go to, yes, 11, not 10. Because remember from yesterday's lesson, if we put 10 there, the numbers that it will generate is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's always 1 less than the last number. In this case, now the numbers that will be generated would either be one of the following numbers. All right. So now that we got what number is going to be generated, I can start my next part of my processing is to see if the person has guessed the correct number or not. And to do this, we write down our if statement. So if, say, right, if the user guess is equal to my guess that I got from my, oh, let's change that to number. So it makes a bit of sense. So the user's guess is equal to my number that I've generated. It means they've guessed the correct number. And I can say them, all right, print congrats, correct guess. Thoughts, I'm going to just copy this entire thing again. Say, all right, if they've not guessed it correctly, so if the user's guess is not equal to, and I made a mistake, there we go. So be double equal to. Because remember, 1 equal to means save. So if the user's guess is equal to the number, congrats. If the user's guess is not equal to the number, sorry. Not correct. Yes. So let's see if this works. Save, yes. Oh, I forgot to save it. Right, so entering a number from 1 to 10, I'm going to go 5. Ah, the wrong number, damn. Okay, let's see if we can get it right next time. But I'm going to cheat a bit. The reason I'm going to cheat because remember, it's going to generate 1 to 10. So I have a 1 in 10 chance of getting it right. So in order to make it a 1 out of 1 chance, I'm going to cheat by just printing the number out first. So if I go print number, so I know what the number is, so I can guess it right, so that we know that the program is actually working. So let's go with it. There we go. Enter a number from 1 to 10. I put it in the wrong place. All right, let's see. 8. Sorry, still not the wrong one. So the correct number was supposed to be 10. So let's see if I put this in the right place, whether I can get the number right. I need to take this out from here, put it before my input in order to cheat. All right, so the number that's generated is 4. So now if I put 4 here, congrats, correct guess. That was me cheating because we got a 1 out of 10 chance of getting it right, and if it continued forever, there's a slight chance that I would have got it right eventually. All right, so put this back in position. There we go. So our program for guessing the numbers are correct. So as I said at the start, this is only one type of if statement where we put an if, we put a condition, and we say what must be done when this condition is true. We put an if, we put a condition, what must be done? when this condition is true. So this is the first part of the if statement that we learned. Now there's other types of if statements that we're going to be going through next. And that is, right? So we learned the first one, the second one. Second one is, if condition is true, what must be done? And you see, there is a slight difference to this, is we can also have an else part. An else part simply means what must be done if the condition is false. So if you notice, we have one condition. So if the condition is true, this work must be done. Else, if the condition is false, this work must be done. We can have one little if statement, but have two outputs for one condition. And if you notice with the programs that we've already done, I'm going to plot just the guessing one, there was only two outcomes for this. If the guess was right, it was correct. Else, if the guess was wrong, it was wrong. So I can change this if statement to go with the second type of if condition, where if the guess is wrong, I can just display a message instead of checking it. And all we need to do in order to do this is change this program and put down the word else. So if we read this out, if the condition is correct, it'll run this line. Else, it'll run this line. So if we run now, we all know I'm going to guess it wrong, right? So 4, there we go. The correct answer was 2, and we've got it wrong. And you can see it message, sorry, not the correct guess. And the reason for this is because even though I took out the entire condition, because there's only two outcomes for the if statement, I don't have to write that entire second outcome. I can just use it as a simple if statement and else, and I can display what must be done if this part is wrong, if this part is false. That's what else does. It runs when the condition is false. And yes, I can go back and I can change the other programs that we did because we only had two outcomes. The person either had the answer right or the person had the answer wrong. So that's how we can use the second method. Now, the third method is a bit confusing or a little long for you to understand, but I'm going to show you it so that you know there's a third version. And if you wish to use it or learn about it, you can. And the third one is we have an if-else condition statement. That means we can put multiple conditions into one line. So if I look at this, I can say, okay, if the condition is true, it will run this line of code that we have here. You notice the difference from the first part of the if statement to the second is we have this little ELIF. The little ELIF simply means else if, and we have a condition. So we can have a statement with two conditions. That's why I said it's a bit confusing, but if you understand it, it makes a lot of sense. And I'm going to show you with the same program that we just did, which is the guessing one. So you noticed before I took away this little line. Right. So what I can do here is I can say, okay, ELIF. What this does is it groups all this into one line of code. In other words, remember when Python is actually running code, it reads one line at a time and processes it. When it comes to line 12, and it says the statement is true,
it won't read 14 and 15 because it's an else if statement. So it'll ignore line 14 and 15 if the first time it is true. If it's false, then it'll read 14 and 15. So that's how the else if works. It's a combination of all your little else ifs together, and it'll only run if the first one was false. So if I can add on to this, if I want to put another message, put another else if there and say, okay, what if the number is greater than? All right. Yeah, that is a little tricky. That's why we normally stick with for the time being, with the if and the else part of Lua. All right, let me save that, minimize it, go to a question. Problem. Oh, and I forgot the last question on that page that I had. Try this out for yourself. Create a guessing game for rock, paper, scissors. With this guessing game, you can allocate numbers for each of the items. So let's say 1 is rock, 2 is paper, and 3 is scissors. So you can try and match up a little game for rock, paper, and scissors and see if you can beat the computer. All right, so that's something for you to try out, and I'll answer it with you tomorrow. See how many of you got it right. All right. Problem. Design a program that will receive two numbers. So we're going to receive two numbers. Since we're receiving two numbers, this is going to be our input. And display which of the numbers are bigger or if the numbers are the same. So this time we are going to be displaying if which of the numbers that are entered is bigger or if they are the same. So if we look at this, I'm going to have number 1 that they're going to enter and number 2 that they enter. And say, okay, what if I take an example of 2 and 3? I can say 2 is less than 3, so 3 is the bigger number. So number two is stored in the bigger number. But now we need to put this in coding. So we can say, okay, if number 1 is greater than number 2, then that means that number 1 is bigger. But then I can also go the other way. Okay, if number 2 is greater than number 1, then that would be in yes, number 2 is bigger. And finally, if you notice, we said, the numbers are the same. What if the person entered two identical numbers? Then I'll have to look at, is number 1 the same? And we don't put down 1 equal to, we put down 2 equal to. So if number 1 is equal to number 2, then that means then it is the same. So this becomes our process. And if you notice, if this is our process, it's going to be written into an if statement because we are testing conditions. We got 3 conditions to test. So let me quickly open up a program for it. Go, file, save. Number is bigger. Right, so we start off this with our numbers. The first thing we're going to do is we're going to have our input. Right, so let's go with our input. Well,
we aren't actually going to have any imports. So if we look at import process, again, I'm going to skip the output part because when we start dealing with if statements, our process and our output becomes one. Sorry about that. Right, so input and process becomes one. So let's start with the input. I can go, all right, number one is equal to input, enter in the first number. Okay, right, number. Of course, because we're dealing with numbers, I'm going to convert this number. So I'm going to say number one is equal to int number one. Yeah, spelled number one wrong again. Don't know what's going on. All right. Next, number two. And be a little lazy and stuff and type in then type in what I can. Just gonna copy and paste it. All right. So number two, number two, two, number two, and it's not the first number, it is the second number. So I've got my numbers. I can now run my process in. We look at what we worked out. If number one is greater than number two, number one is bigger. So again, process in. If number one is greater than number two, print is bigger. One plus number two. Of course, I need to firstly, if I can test anything out, change this two into a string. Yes, because I'm using text. So string in front of both. And I can test whether this works. So if we enter the first number is 4, the second number is 2, 4 is bigger than 2. I must have then. Okay. Because if I run it and I put the first number as 45 and the second number as 60 or 50 in this case, nothing happens. Reason? Yes, we only coded for the first number being bigger than the second number. We didn't code for the second number being bigger than the first number. So we need to just copy and paste the same code and do a little bit of changing. So copy and paste it to change it. So now I'll test if the second number is bigger than the first number. And if the second number is bigger than the first number, it means the second number is bigger than the first number that's been entered. Quickly run this to test it. Go 23. 3, 50. 50 is bigger than 23. So the second number is bigger than the first one. Of course, we're not done because we got the first number and the second number. But what if I go and enter 3 and 3? See, nothing happens. So I now need to code for that outcome. That outcome is both the numbers are the same. Let's go with this. If number 1 is equal to number 2, then I can print out both the numbers are the same. So now we got a little program to check what type of numbers we are using. So I can go, okay, 5 and 5. In this case, both the numbers are the same, so none is bigger than the other. All right, so you can quickly save, file new. Ready for the next question. All right, next question. Design a program for a restaurant that will calculate the amount of tip or the amount of tip a customer needs to leave for the waiter based on how much they spend. So we're going to calculate the tip amount. So how much of tip that you need to leave behind when you are leaving the restaurant. And we've given two little ways of calculating it. And we calculate it based on how much they spend. If the bill is less than equal to, it's really important, it's less than equal to 500. So we go, if that bill is less than equal to 500, then the tip will be 10% of the bill. So now we need to work out what is 10% of a bill. So I can say, okay, it's the tip amount is equal to the bill times 10%. So it'll be 10 over 100. Why 10 over 100? Because it's 10%. Whenever we see percentage, means take the number in front and divide by 100 when we want to use it in a calculation. So we're going to say 10 divided by 100. When the bill is more than 500, so it's more than 500. So when the bill is more than 500, then the tip is going to be equal to the bill times 15%. So percentage mean take the number in front, divide by 100. So it's 15 over 100. 15 divided by 100. So now it's time to do the calculation. Right, let me go back to my program. I can find which screen it's on. No, not that one. Is it this one? There we go. Right, so let's start with it. Import, we're not importing anything. Input, are we going to input anything? Yes, we're going to input the bill. We're going to say bill is equal to input. And now I can say enter the bill amount. Just to be fancy, we can put a little currency there, whether it's a rand or any other currency we want, dollars. Just put it there and look like they're entering that amount. So just rand there for the time being. Then quickly go and say, all right, the bill is equal to, not end, because a bill can have decimals. You can know decimal numbers like 10 Rand 50 or $3.39. So it has to be float. So I'm going to go float bill. Now that I've got that, I can start my processing. Ooh, what happened? So I can start my process, and my process will be, all right, check in. I'm going to check, is that bill less than equal to 500? If that bill is less than equal to 500, then the tip is calculated. So I'm going to say tip is equal to the bill amount times, and since I'm going to go 10 over 100, which is 10 divided by 100, I'm going to say, ooh, okay, everything just wants to erase. 10 divided by 100. And you'll note, oh, that's why we're still getting clicked on. All right. And you notice I'm putting this within brackets because I'm using BODMAS. I want the division to be done first, then I want the multiplication. Okay, so I can finally say, all right, print the tip for the waiter will be, say again to make it seem that I put down currency, will be and string tip. Now I can see if this works. I need to save it first. Save it as full. All right, so I'm going to quickly run it. Enter the amount, and you can see I got an R over there because I put the R in the text. So I can go, okay, I'm owing 100 Rand for the bill. And if I look, the tip for the waiter will be 10 Rand. Why? Because it's 10% of 100. Then let's go and try a different amount. 500 and 50 Rand. See, nothing happens because the bill is now bigger than 500, and we only, yet it's only bigger than 500 by 50 cents, it's still bigger. So we now need to code the more than 500 part of it. So all we're going to do is we can just copy the same thing again, because that's our process. It's the same thing, but with just a different signage. So this time maybe greater than 500. When it's greater than 500, according to my question, the bill is 15%, or sorry, the tip is 15%. So now I go put a 15 there instead of 10. Now I can run this. And now I can go, okay, this time it is 550 cents. And you can see now the tip for the waiter is 75 Rand 075. Because what can we do with this? We can always round it off because we don't have that 075 cents. And all that means we're going to do is we're going to use the round function. So we can say, okay, before we display the tip, we can always go round and round the tip off. Since we can round it up to 2 decimal places or 1 decimal place, we put down what decimal places we want there. Let's put 2. Makes it more easier to understand.
Now if I go to 550 cents. Oh, what happened? The tip for the way tool will be 75 and 07 cents. Oh, did I save it? I didn't save it. See that what happens when you do a calculation and you don't save the calculation. It doesn't get stored. So I need to make sure that this is always saved in tip. So I'm going to calculate it and save it back into tip. So because I didn't save it, it gave me that original answer that I had. I'm just going to close the screen. It's gone right to the bottom. Let's run it again. This time, and I put 550 cents. Now 2 decimal places. It's now 75 Rand, 8 cents. Right, so now that's done. Let's go on to the next part. Next part is our logic operators. You see, we can have separate conditions on a if statement, and then we can have combined conditions. And in order to combine two statements together, we can either use and, or, and not. Those are our three conditions that we can use to join two if statements into one. So let's say I wanted to see if a mark was greater than 0 and less than 29. That's now two conditions in one. So you need to understand how the operators work. The AND operator returns if both the statements are true. For example, if I say A is 3, if I look at this outcome, is A less than 5? That's going to be true. A is less than 5. Is A less than 10? That's going to be true. A is less than 10. So because I have an AND between both of those statements, my result is going to be true. That's what the AND works with. Both sides of the AND must be true in order for us to get a true answer. But it returns false if one of the statements is false. So using the same thing again, but changing the numbers, I'm saying A is equal to 6. Is A less than 5? That's false. A is not less than 5. A is greater than 5. It's 6. But then if I go and look at the next statement, is A less than 10? That's going to come back with an answer of true. A is less than 10. And if I look at both these statements, this is going to be an answer of false. And the reason for this is because one of the answers is false. Right. Then if I look at the or statement, returns if one of the sides of the statement is true. So it doesn't matter which side is true, as long as one is true, the answer is going to be true. If we look at A is 6, this is going to be false again. This is going to be true, but because one side was true, our answer is going to become true. And the not part is really simple to understand. Not means not what we're looking for. So if our answer is true, and I say not true, what is not true? False. The answer is false, and I say not false, becomes true. It says the opposite. So not changes our answer to the opposite of what it's supposed to be. So if I tell you your answer is yes, and I say you not yes, the answer is no. That's our logic operators, which we'll be using in tomorrow's lesson. Now, before we go on to end the program, I want to show you the last slide. This one. Oh, yes, the competition slide. Right. For the competition slide, for those of you all that's working on your projects or the coding that we have done, there's 2 links to put your projects up in. If you're in grades 7 to 9, this is the link you're going to use to upload your project, those of you all that registered for it. And if you're in the FET phase, grade 10 to 12, you're going to upload your project into this link. I'm going to copy this links and put it into chats. Right, there we go. So the first link is for uploading your projects in the grade 8 or 7 to 9 platform. And the second link is when you're done with your project, whatever project you want to make using code, and upload it into the second one, if you grade 10 to 12. Right, so that's the end of today's lesson. Thank you so much for joining me today, and I hope you have a good afternoon. I'm not sure, Lee, what version of Windows are you using if you couldn't install it?